Hi students, welcome back. In this video, we are going to look at implementing a trie or a prefix tree. A trie is used typically to store for the efficient storing and retrieval of data. Okay, it is used in use cases where you have to do autocomplete or spell checker. For example, when you do a Google search, it will automatically suggest certain things, right? You can use trie for such use cases. So how do you, what are the methods we have to implement? We have to implement initializing a trie, inserting into it, searching into it, and starts with. Okay. And the given question states that this trie consists only of lowercase English letters. That means A to Z, which is 26, all lowercase. It doesn't have any other set. So typically a trie will have all the input data set defined, like all the characters possible. So if there are uppercase letters are also allowed, then you'll have 26 plus 26. If numbers are also allowed, then it will be plus 10. If special characters are allowed, you'll also have to add them. Like that, each node of a trie will increase based on the allowed letters in it. Okay, so let's understand the trie data structure first. So in our example, we will consider a trie with just four alphabets. Let's say we have only A, C, R, T. So in the given problem statement, it said it contains A to Z and all 26 letters, but here in our case, it's just A, C, R, T. Okay, so in trie, every node has pointers to for all the character set it represents. Okay, let's say we represent a node as a array list of trie nodes. Okay, so we have four characters. So let's consider the indices like this. So 0, 1, 2, and 3. 0 represents A, 1 represents C, 2 represents R, 3 represents T. Okay, so when there is an edge from zeroth location of the trie, that means a character A exists. Okay, uh, a pointer or an edge indicates the existence of a character in trie. So let's see how we will insert cat in this. So cat is let's go character by character. So first we will look at C, how to insert C. So initially when you initialize a trie, it's an empty node like this, whatever we have right now. So when you are inserting C, C is at position 1 in our vocabulary list. Okay, that means 1 should have a node, and that node would be again all these four sets. Okay, okay, so 1 has a node, so this indicates C, existence of C. Okay, so each node in a trie has uh, a character representing what character it is, and it will also have a flag. This flag is a Boolean flag which can have true or false. So whenever we insert a node, by default for this node it's false. Okay, only at the end of the word. That means in case of cat at T, this will become true. So C is not end of the word. So for this node also it will be false. Okay. Then for cat, then the next letter is A. So we have already inserted C. Now we have to insert A. A is at position 0. So here we will insert another node. Okay. And is this end of the word? No. So this will also be false. Okay. So this represents A. Now we have to insert T. Okay. So T is at position 3 in a input list. So at 3 we will add another node. T is position 3. Okay. And this is end of the list. So for this, the boolean which specifies end of the list would be T. So this is not a pointer. This is just another value in the node. That's all. Don't get confused by arrow notation. Okay. So for this node, it's false. Then when you add C from pointer position of C, which is 1, we add a pointer and the value of it, the is word flag of it will still be false. Then we add A, then we add T. For T, it will be true because it is the last word. Now let's say we try to insert car. Okay, for car, C is already there, A is already there. Now we have to insert R. R is at position 2, which means from here there will be another point. Okay, and for this, is word flag will be true. This represents R. Okay, now let's insert cart. C-A-R-T. C-A-R is already there. T is at position 3. Okay, so from here we will add another pointer. Okay, and for this also is word flag will be true. Okay, now if we insert art, here so far we don't have A, so we will start a new node for A. Okay, we will start a new node representing A. Okay, here this would be false. This is A. Again for R, you will have another value. Okay, this would again be false. And for T, you will have another node, and end of the word would be true for it. Okay, so that's how you insert letters. Now, when you are looking for a letter, let's say word, let's say you are looking for car, you'll start at the root node. You'll see if C is at position 1, right? So if position 1 has next node, it does. Then the next character is A. So position of A is 0. You'll check if 0 has a character, a next node. Then the next letter is R. You'll check if the position of R, which is 2, has next letter. And you are looking for a word. That means at this point, the is word should also be true. In that case, you'll say that car exists in this trie. And if you are looking for all the words that begin with CAR, which would be CAR and CART, then everything in this list would form that. So CAR is common and everything in this tree would give you all such words. Okay, that's how you do a search. And now in this case, if you are looking for, let's say, TAC, a random word, T doesn't have any next pointer here. So that means nothing exists for T. So you can immediately return saying there is no word TAC in our trie. Okay, that's how you implement a trie. So each node will have an array of pointers pointing to next node of each of the character it represents, and also a flag called is word, which will be true if the word ends at that character, otherwise it will be false. Okay, so now let's implement it and see. Okay, so we are already given the functions we have to implement. The first thing we need is we have to define the trie node, right? The one where we said it has array of pointers. So we are saying it will have array of pointers. So pointers are nothing but itself children, and it will also have a flag which represents whether that is a word or not. Okay, and let's add a constructor to it. So when you initialize a node, you want all the children. So our problem statement said it has 26 characters, all the alphabets lowercase. So the children array should be of size 26, and by default is word is false. So that's what we will do in the constructor. Okay. So now when we initialize a trie, what we will do is we will just initialize the root node. So for that, first let's define a root node. Okay, let's say we have a root node. Now, when we initialize a trie, we will just say this will give us that empty node which we initially defined. Okay, now let's look at implementing a word. Okay, so inserting a word. So let's say the current node is represented with node. So initially to start with, root is our current node. So then what we have to do is for each character in this word, okay, this will give us all the characters as an array. Okay, we will see if the trie node has a node at that place. Okay, to see that, what we have to do, we have to implement a get function in our trie node. So you have to check if there is a node at for character C, right? So let's say we call something called get with character as input. Okay, so how do you return the node at that character? We are representing them as alphabets, right? So 0 represents A, 1 represents B, and so on. So for a character C, to get the index of it, you can do C minus A's character value. Okay, so for A it would be 0, for B it would be 1, and so on. So this is how we will get node at character C. Okay, so now when we are inserting, there will be two cases. If a node exists at that position with that character or not. So if an first let's get the node. So if a node exists, then new node would be whatever the value that is. If a node doesn't exist, that means when you get it, if you get null, that means you have to create a new trie node for that position. This is in our example, the first time when we were inserting C, nothing existed. So you'll have to create that node and you have to put that in the array of the current node. Okay. So that means we'll have to implement a put as well. Okay. So how do you do a put? So what we are doing, we are putting a character, we are putting a node at a character. That means we have to put this node at that position of the character. Position again comes from this logic. Okay. So we can do children of C minus A equal to this node. That's all. Okay. Now we defined a node. We have to put it at that location for that character. Okay. Now we have the node. So whether the node exists or not, we will get this new node. Okay. Now we will just initialize it. So we have the new node. Now when we go to the next character, we will repeat the same process again. So at the end of it, we will reach the end position of this uh, okay, of this word. So there is one more task we have to do at the end position, which is we have to set the isWord flag to true. Okay, so let's write a helper function in trie node to set the isWord flag as well. Okay, now we can just call this in a insert word function. Okay, so we'll just say node dot isWord is true at this point. So we have inserted all the characters. We have reached the last node. At this position, we are saying that the last word isWord is true. We are saying we have inserted a word now. Okay. Now let's look at implementing search. So search also does a similar traversal. So let's just copy paste this thing. So we will start with a root node. We will get the character array of it, and for each character we will get the node. Okay, when you get the node, if new node is null, okay, that means there is nothing there. That means we can just return false here. Okay, okay. If we didn't return, we can say node equal to new node, or we can just call this node itself because we are anyway returning. Okay, we get the node. If node is null, we return false. Node is null meaning nothing exists at that point. So for this character, there is nothing. That means there is no chance this word will be in that trie. Okay, and let's say everything existed. Okay, that means we have reached the end of the array. That means for CAT, we have traversed till T and our node will have a T's pointer. So in that case, what we will do is we are checking if a word exists. So we have to return if that last node is a word. Okay, we have to return the is word flag of it. So far we don't have that method in trie node. So let's add that as well. Okay. So if we successfully traversed all the characters, we will return the last characters is word flag. Okay. If we didn't traverse or if we didn't find any character in between, that means the word doesn't exist and we'll just return false. Okay. Now let's look at the third function. So the third function will also be very similar to this. So we start with the root node. Okay. And we get the character array. Okay, here it is called prefix. So we get the character array of the prefix. So for each character, we get the node. If a node doesn't exist, even here we'll return false. Okay, but if all the letters exist, we are looking for a prefix. We are not looking for a word. So whether the word is end of the word or not, either way, we have to return true here. That's the only difference. So you have to understand the difference between search and starts with. Search is true only if the last letter is end of the word, whereas starts with is true even if the last letter is not end of the word. So in our dictionary, if we were just searching for CA, this one should starts with should return true, whereas search should return false. Okay, so let's run this and see. Okay, try node equal to node dot get. Good. Okay, we don't have to define this thing again because it is already defined. Okay, so let's submit this and see. Okay, so it got accepted. So we looked at a new data structure today. Trie is one of the important data structures for efficient searching of the strings. So please go through it and implement it yourself. So as always, keep practicing and happy coding. If you like the video, please like, share and subscribe. Thank you.